Good day, everyone. I'm Arvin Enriquez, your subject teacher in General Mathematics. With this video lesson, we're going to discuss the topic Domain and Range of Exponential Functions under your General Mathematics from Quarter 1, Module 20. Our lesson objectives. At the end of this video lesson, you are expected to define the domain and range, find the domain and range of a given function, and represent the domain and range using the set builder and interval notation. So the domain and range. The domain of a function is the set of input values that are used for the independent variables. Yes, no? The domain, that will be your input values, your x values, that will serve as your independent variable for a given function. Now, the range of a function is the set of outputs. So this will be the outcome. So whatever we input as the values of your domain or x variables, no? So whatever the resulting value, so that will be your range of a function. So this will be a set of output values for the dependent variables. Yes, it is, no? Because whatever we input a values, no, or whatever values that we put, no, as a value of your x variables or your domain, it will affect the value of your f of x or your y, or it can be your output values or your dependent variable, which is your y. Now, for any exponential function, f of x is equal to b raised to x, and we need to satisfy, no, before we conclude again that the given is an exponential function if and only if there are two variables involved, your independent and your dependent variable. Your independent variable being your exponent value, no? Your exponent to your base, which is greater than 0 and not equal to 1. So if we satisfy all those considerations, no, before we conclude that the given is an exponential function, then we can conclude now that the given or givens, no, are exponential functions or function. So the domain is the set of all real numbers. Why is that the domain is the set of all real numbers? Because your exponential function here, no, will never intersect, no, or there is no intersection between your x-axis and your graph. So the range, however, no, is bounded by the horizontal asymptote of the graph of f of x. Yes, it is, no. Most of the time, the range can be all positive values. There are times that your range are negative values. Unlike to your domain, once you're dealing with your exponential function, it's always a set of all real numbers. So the values of your domain will be from negative infinity to positive infinity. So those are things that we need to consider, no, once you are dealing with your exponential function. So for example number 1, so we're asked to find the domain and range of a function which is your y is equal to 3 raised to x plus 2. So our solution, so look at the graph of the function. As you can see, as your x increases here, no, if we start from here, as your x increases going to this point, no, then your y also increases. If your x increases, it's automatic that your y also increases, meaning to say it is an increasing function. Because if x increases from negative values going to a smaller negative value, no, then your x also increases here, as you can see, based from the graph. So the function is defined for all real numbers. So the domain of the function is the set of real numbers as x extend to approach positive infinity. So the value of the function also extend to negative infinity, and as x extends to approach negative infinity. So meaning to say there is an extension here. So if we're going to extend this graph, it will pass through, no, your y-axis. So I mean to say that there is a point of intersection between your graph and your y-axis. So that's why, no, that your x-axis now will serve as your asymptote. That's why the function, no, approaches the x-axis but never touches it, because there is no point of intersection between your x-axis and your graph here. Because at some point here, as you can see on this graph, no, at some point there, the your graph becomes parallel to your x-axis. If they are parallel up to the last part of this graph, meaning to say that there is no point of intersection between your graph and your x-axis, that's why it is the reason, no, that we can conclude that your x-axis is your horizontal asymptote for this graph. So therefore, the range of the function is a set of real positive numbers greater than 0. Yes, it is greater than 0 because your 0, 0 here is at the center. Meaning to say that your graph will above or parallel to your x-axis, meaning to say that the lower part of this graph, no, will never pass through your x-axis, and the value of each y-coordinate in each lower part of this graph is greater than 0. That's why the range of this function is a set of real positive numbers, because we only consider your positive y values, because your graph will never uh, touches, no, your x axis, or there is no point of intersection between your x-axis and your graph. That's why your y now, or your range values, no, or your y values is an element of all real numbers. And there's a given condition here that your y is greater than 0. Meaning to say that all numbers greater than 0 can be a value of your range of the given function. So it can be positive 1, positive 2, up to positive infinity. Thus, no, we conclude, no, thus the domain and range of the given function is given below and can be written as, so using your set notation, that your x, no, such that your x is an element of all real numbers. So based on your graph, your x can be negative numbers up to positive numbers. So we can start from negative infinity going to a positive infinity including 0. So meaning to say that your x can be an element of all real numbers. That your range now, your y, such that your y is an element of all real numbers, but again there is a given condition that your y is greater than 0. Meaning to say 0 to negative infinity, these are values that cannot be a value of your range here for the given function, because your y or your range here is greater than 0. So for the interval notation, no, the interval notation is that you will start from negative infinity up to positive infinity because your x is an element of all real numbers. We can consider, no, all your negative values including 0 up to your positive infinity. That's why we can start from negative infinity to positive infinity. Now, for your range, no. So your range, no, your interval notation is that it will start, no, or the range will fall in between your 0 and positive infinity or equal to up to the last value of your positive values. So that's why it's 0 and positive infinity in a way that your value of your range will fall in between your 0 and the last positive values that we can consider for this graph. So that will be the value of your range for this example number 1. So for example number 2, so find the domain and range of a function. Your y is equal to 1/4 raised to 2x. Your given is an exponential function because there is an involvement of your x and y variable. X, that will be your independent variable and as a part of your exponent. So for the solution, look at the graph on the next page in the coordinate plane. So this graph is a part, no, will be the part of the next page in your module. As you can see, no, in your module, this will be a part of your next page, no. So as you can see in this value, no, when your x increases, no, from negative values up to positive value here, when your x increases, no, as the as your x increases, no, then your y value decreases. So meaning to say that this graph represents a decreasing function. So the function is defined, no, for all real numbers. So the domain of the function is the set of real numbers. Yes, it is always a set of all real numbers once you are dealing with your exponential function. As x tends to approach positive infinity, the value of the function tends to approach 0. And the graph approaches the x-axis but never touches it. Yes, it is the same scenario, no? Same thing with your example number 1, that your x-axis will serve as your horizontal asymptote, meaning to say that there is no point of intersection between your x-axis and your graph approaches, no, your x-axis but never touches it. So as x tends to approach negative infinity, the function also tends to negative infinity. Therefore, the range of the function is the set of real positive numbers greater than 0. It is the same thing, no? It's the same scenario with your example number 1. If your graph will never intersect or will never pass through, no, your x-axis, meaning to say that your domain or your y values are only real positive numbers. So there is no such thing, no, with that condition that there is a negative value for your domain, for your range, I mean, or y values. So for your notation, your y, such that your y is an element of all real numbers, and there's a given condition here that your y is greater than 0. So supposed to be that your y is greater than 0. So it will start, or it will fall, no, from 0, in between your 0 and your positive infinity. So here in the set notation, interval notation, it's the same thing on the set notation and interval notation for domain and range in your example number 1. That in your domain, it is that your x, such that your x is an element of all real numbers, because there is no point of intersection between your x-axis, meaning to say, no, your values can be, we can start your values from negative infinity going to your positive infinity, then your range, your y, such that your y is an element of real numbers, that your y is greater than 0 because there is no point of intersection between your x-axis and your graph, meaning to say that there is no negative values, and 0 as a value of your of your range. So your interval notation for your range, it will start from negative infinity to positive infinity, or it will fall no in between your negative infinity and positive infinity. So in your range, it starts from 0 to positive infinity. The values of your range will fall in between your 0 and positive infinity. Or it will start greater than 0 up to the last value for your, up to positive infinity, I mean. So that's how we write no, a set notation, interval notation for this domain and range of your exponential function. So the domain and range of exponential functions, so let f of x is equal to a multiplied by b raised to phi of x plus h be an exponential function where p of x is linear. So we should check first no if your p of x is a linear function. So if not, then we cannot conclude that this is an exponential function. So then, no, the domain of the function is real numbers, and the range of the functions wherein it starts from h to positive infinity if a is greater than 0. So I may say that the value or the interval notation for this range of the function will be dependent no, on the value of constant here, which is your a. If your a is greater than 0, then it will start from h to positive infinity. So if your a is less than 0, it will start from negative infinity to h, or in the interval of negative infinity to h. So that will be your range. So in cases of an exponential functions where p of x is a linear, so what is linear? Meaning to say these are equations that represent, or this is a functions, no? These are functions, I mean, that represent a line. In which case, your b raised to p of x will always define for any value of x. Yes, it is, no? Thus, the domain of an exponential function is the set of real numbers R. For the range, note that your p raised to p of x is greater than 0 for any values of x. So you need to check, no? So if we put a values of x to your p of x, then the value of your b raised to p of x should be greater than 0. So there is no such thing as negative value for this one, no? So you need to check first. So hence the range of an exponential function will depend on a and h. So there are two considerations here, your a and h, for you to decide for the values of your range of an exponential function. So in your example number 3, so let f of x is equal to 3 raised to x, and we're asked to find the domain and range. So for the solution, so the domain of a function is the set of real numbers, since f of x is equal to 3 raised to x is defined for any real numbers x. Yes, no, it's automatic na once you're dealing with your exponential function, it's automatic that your domain is a set of all real numbers. Why? Because it will start from negative infinity to positive infinity, including 0. So the value of your domain or variables, no, or your independent variables, I mean, will start from negative infinity to positive infinity. So it means that any value of x from the set of real numbers can be substituted to variable x. Yes, it is, no? Note that any power of 3 is always positive. Yes. Hence, the range is 0 to positive infinity. Why is that? The value of your range, no, will supposed to be fall, no, in between your 0 and positive infinity. Why? Because your graph of an exponential function will never pass through, no, in your x-axis. And your x-axis will always serve as your horizontal asymptote once you're asked to graph, no, an exponential function. That's why here it's the same scenario, no, in your domain, that your domain is an your x, such that your x is an element of all real numbers, meaning to say we can consider that negative infinity up to positive infinity, including 0. So these are the possible values of your domain, no? Once you're dealing with your exponential function. For the range, since there is no point of intersection between your x-axis and your graph, meaning to say that the y values or your range is supposed to be, no, or it should be, no, it should be greater than 0. Even if your y is an element of all real numbers, but there is a given condition that your y should be greater than 0 all the time. So that's why the value of your range will fall in between your 0 and up to the last value of your positive, or that will be your positive infinity, So meaning to say that your y are positive real numbers which are greater than 0. So for example number 4, so let f of x is equal to 4 raised to x plus 1 minus 2. So we're asked to find domain and range. So here there's an involvement of your linear function as your exponent. There's a value of your a and h, which is supposed to be no, wherein your range will always be dependent on the values of your a and h. So the domain of the function is the set of real numbers because p of x, or the function of p with respect to x, is equal to x plus 1, and it is linear. That's why you really need to check if the exponent is a linear function. So also, no, in the given function, you may observe that your a is greater than 0. So what is the value of your a? So your a here is equal to 1. As you can see on your exponent, that will be equal to 1. And b now is equal to 2. So your base will be equal to 2. And h is equal to negative 2. So here, as you can see, the values of your range will always be dependent, no, on your a and h based on the given function. So hence, the range of the function is equal to h, or the interval notation is h and positive infinity. So for the set notation and interval notation here, so for the domain, it's the same thing, no? As long that you're dealing with your exponential function, it's automatic that your x is an element of all real numbers, meaning to say that negative numbers, 0, and positive numbers can be considered, no, as a value of your domain in this exponential function. That's why your x is an element of all real numbers. And your range, your y, such that your y is an element of real numbers, that your y is greater than negative 2. So meaning to say, the value of your y can be what? Can be negative 1, 0, and positive numbers. So those are numbers greater than negative 2. Those are numbers that can be, or can be considered, no, as a value of your range. So for your interval notation for your domain, so again, we can start from negative infinity up to positive infinity. It's the same scenario. So for your range, so from 0, negative 2 to positive infinity, and the value of your range should fall, no, in between your negative 2 and positive infinity, or the maximum value is your positive infinity, as long that your y, or your range value, is greater than negative 2. So that will be the value of your range for this exponential function. So for example number 5, so let f of x is equal to negative 2 raised to x minus 1 plus 3. So we're asked to find the domain and range. So the domain of the function is the set of real numbers because p of x, no, or your function p with respect to x is equal to x minus 1, and it is a linear function, no? Also, in the given function, you may observe that a is less than 0. Your a is negative 2. Yes, it is, no? And your b is equal to 1 half. And your h now is equal to positive 3. Again, the values of your range will always be dependent on the value of your a and your h. That's why, hence, the range of the function is equal to negative infinity up to your age. Now, how can we set your notation, interval notation for your domain range? For your domain, it's the same scenario from example 1 to example 4, that your x is an element of all real numbers. So we can start from negative infinity to positive infinity. So meaning to say negative values, positive values including 0, these are values that can be considered no, as a value of your domain. And for your range, so there's a given condition here, even if your y is an element of real numbers, your y is less than 3. Then the value of your range, no, will start from negative infinity to your 3. Why? Because there's a given condition here that your y is less than 3. What we're trying to point out here, meaning to say that the value of your range will start from negative infinity up to your positive 2 because positive 2 is less than 3. So the value of range will fall no from negative infinity to 2. And all the values no as long that the value of your range is less than 3. So that's how we set no the notation or an interval notation for this range for this given exponential function. So for your activity, so answer the guide questions to complete the table of domain and range of the following exponential functions. So first one is your f of x is equal to 5 raised to x, and your for letter B, your f of x is equal to 1/5 over raised to 3x, I mean. So you're asked to find the domain and range of this one, and you can use the guide questions no for you to complete the table. So you can write your answers and solutions no in your Katleya notebook. For watching, so please like and comment and subscribe.